setup. Laura Niles will be our next presenter. And let's see. Laura has been with the state of California since 1990. She's been with the Air Resources Board since May of 2007. She is currently with the Quality Assurance Section conducting air monitoring performance audits throughout the state. Laura attended the California State University of Sacramento, where she received a Bachelor of Arts degree in Geography with an emphasis in Physical Geography Planning, and holds 2 Associate of Science degrees from community colleges for the U.S. Air Force for both aircraft maintenance and flight engineering. Laura's presentation today is entitled Residence Time. It's about time and pressure.
Okay. Now, sorry about that. This is going to be hard for me because I know Eric has arms, I got legs, and I like to move around. So I'll see what I can do because I know we're on camera and I know the camera doesn't want to follow. So anyway, we got hit pretty hard on our TSA for residence time. So we're going to go over residence time. How long, what is it? Does anybody here not know what residence time is? Go ahead. I mean, a lot of us aren't here that are in, right, okay. A lot of us here aren't in air monitoring. So it's how long it takes air to go through the probe and into the back of the instrument to analyze it. The parameters we include are ozone, NOx, CO, SO2, H2S, and non-hydrocarbons, non-methane hydrocarbons. It's measured in seconds, and it has to be defensible in court. How do we make it defensible in court? Documentation, right. So that's what the EPA really had a problem with. Many people met the 20 seconds. They just didn't document it. So that's what we're here today to do, is to show you our spreadsheet and how to document it, and for you to use our spreadsheet, because it's a lot easier than screwing up the math. Here we go. So the importance of it, the reason it has to stay under 20 seconds is because we want to make sure that ozone doesn't react with other gases. Remember, we talked about the trees and the scrubbing. We don't want scrubbing to happen inside the probe. Again, this can be found in Appendix E, 58. But one thing it says about the 20 seconds is that it should meet 20 seconds. But there's a place where it says must. It must be 20 seconds. Studies say it can make 10 seconds. So our data quality objectives say, let's try to get it under 10 seconds. But for NO2 sites and for NCOR sites, it must be under 20 seconds. Here's your typical air monitoring site. You've seen this picture already today. One thing that I don't see a lot, I see a lot of these at ARB sites, and some of these are even being taken away, is how to measure the pressure drop. And why is that important? It's important because we want to make sure that if you have a kicker pump or a booster pump on your probe, we don't want you to overcome your instrument pump pressure. So again, we're going to document that, and we're going to make that defensible. Here's an example. A magnehelic is installed into your system, and then it is tapped off your manifold. Let's see if I can do this. Okay, so, sorry about that. Your pump is located down here. Air is being drawn through your probe into your manifold, and see there's an inner glass there, and then air is going to come down through here, and the pump is located on top. ARB actually has an SOP that tells you where to place these connections on your manifold. In this case, the magnehelic is in the yellow square. I believe ozone's at the bottom. Is that correct? Yeah, ozone's at the bottom. And I think Phil's probably going to go a little bit into that. No? Okay. Yeah, it's one of the things you had to cut. All right. Anyway, that's one way to measure it. Things that we use for measuring when we come out as auditors is we use the calipers, the flow meter, and a measuring tape. We need to obtain the internal diameters of the probe tubing line, manifold, and filter holders. We need to obtain the probe manifold and holder lengths and obtain the flows from your analyzer. It really, really helps if you guys have this for us, because usually it's on the manufacturer's packaging. There's two different types of tubing. I'm going to pass this around. There's thick-walled tubing, thin-walled tubing. They have different diameters. A lot of you guys know what your outside diameters are, but you don't know what your inside diameters are. So I'll just go ahead and start. So when you're replacing your probe line, if you could leave little samples out for us to measure, that would be really helpful. So that way we're not trying to determine what it is when we go into your site. I know a lot of these sites are 20 years old. The tubing's never been replaced. So again, this is how we do it. It's a little time consuming, but it's something that's got to be done. It's really helpful, though, if you guys know these measurements already. Here's our spreadsheet. You're welcome to use it. It's on our website. It's done in Excel. See, if you can see at the bottom, there's all kinds of measurements and tubings that we try to guess what you guys are. But if you guys really know what it is, that's very helpful. Okay. We're going to look at the probe itself, the vacuum pump, and what your vacuum pump is. A lot of people don't know what their vacuum pump is drawing. It's really helpful to know what your vacuum pump draws. I know a lot of these sites, you inherited these sites from the guy that retired before you. Just take some interest and find out what your stuff is reading, and that way it's helpful when the auditors come out. It speeds up your audit, and we all want to do that. Your manifold, and we're going to measure down to your line. So we're going to go ahead and go through the spreadsheet real quickly and see how it's filled out. So that way, it's not really intuitive how you fill it out, so that's why we're going to go through it. And your other side. So in this case, our probe is 4.7 meters long with the inner diameter of 6.4 meters. We're going to place that on our Excel spreadsheet in the left side where it says probe. Next, we're going to find out what your vacuum pump pressure is. Hopefully you'll know that. Most people do, but there are some people that don't know it. And we're going to place that up in the upper left-hand corner. If you can see, this is color-coded. Carissa helped me with this. She was able to get this all nice and pretty. And we're able to put our pump pressure in there. Flow. Yeah, exactly. Manifold length and inner diameter. This is probably the hardest thing for us to get because we don't know the inner diameter. And where do you measure the length from? Do you measure it from the little nipples on the outside, or do you measure it from the inside? So these are just questions that we come up with that we don't really answer. But you should fill the whole thing, right? Because the whole thing's being filled with air. So you should know the volume of the whole thing. Again, that is put in here. So we're 46 inner diameter and... Yeah, these glasses, it's okay, and 30.30 meters length. Next is going to be our length. This is probably the easiest thing to measure because I'm measuring it from inside your station. It's from the manifold to the back of the instrument. And the inner diameter in this case is 2 meters, and the length is 2.68 meters. And our flow off our instrument is 0.754. We're going to add all that into our first pollutant, which is ozone. And as we populate this, it'll populate automatically when you guys do it, but for purposes today, we're going to show it all at the end. So again, we're going to go to NOx. This is pretty much your standard stations out there now, ozone and NOx. 3.13 with the inner diameter of 3.2. Our analyzer's running at 0.850 liters per minute. And populate that. And all the lengths and internal diameters and flows are collected. Boom. If it was this fast in really life, we would be out of your hair really quickly. But it's not this quick. Anyway, residence time for each analyzer is given. So obviously at this site, these are actual real sites. So at this site, we've achieved 4.69 seconds. So the bottom line gives it to you in seconds, your total residence time. Okay, so here's the question of the day. If you take an analyzer offline, which many of you are doing, a lot of people are taking CO offline. No longer people are using CO. I guess obviously you've talked to EPA first, right? And ARB. We learned that today. So will residence time increase or decrease? What do you guys think? Up or down? Up? Well, you got a pretty smart crew here. Okay, let's see. Okay, we're going to take the CO offline, and if you take a look at ozone, keep your eye on ozone. It's 4.69. We're going to take the CO offline. We've now gone to 4.86. It doesn't really matter when you're under 20 seconds, but when you're getting close to that 20 seconds out there, when you take something offline and you change it, it can make a huge difference. So just be aware. And then also you want to document that as well, that you've taken that offline. This has been an issue lately. These are a new filter holder that we're finding out there. A lot of the thermal systems have them, and a lot of the API people are starting to add them. These are quite expensive. Phil, do you know how much these were? Yeah, they're pretty expensive. I think Jaime, do you know? No, I haven't bought one yet. Oh, you haven't bought, okay. They were already installed when you got there. Okay, yeah. So, yeah, their sites have them. But what we noticed was, because they're so large, that it's actually, well, let me go through this first. We've had to change our Excel spreadsheet because now we no longer have one line diameter coming into our site. So from the manifold to the back of the analyzer. So we've had to change it to allow for a multiple diameter requirement. And how we've done this is this being the new filter holder, we've increased the length of your line by this much. That's how much change is made in this residence time. So that's I think it's a good graphical information that no one calculated for this filter holder size when they installed these new filter holders, and it could increase your residence time greater than 20 seconds very easily. So these are the new blocks that were added, and we're going to get a new time. This is an actual site. If you notice, your numbers are pretty much the same. In this case, we have a 3.2 inner diameter, and then we have a 2.68 length from your manifold to your instrument. Pretty standard, right? And if you look at the time, it's 4.88 seconds. The big difference with this one is that it's now this is the 1.7 liter, so this is a thermo instrument. So because the draw is so, you have such a big pump with the 1.7 liters, it's only causing about 2 seconds difference. But later we'll see today that it's going to cause quite a bit of difference when you go to an API instrument. 38.1. So the only reason it kind of looks like this is because it's the way we had to accommodate it on the Excel spreadsheet. You'll be able to type those numbers in, but in order to do it graphically on the PowerPoint, I had to kind of let it go in by itself. The 3.2 will mean nothing to you folks. It only means something to us. It's something to do with our system. So, but it will calculate your seconds properly. So that's what we added with the two new little blocks. And even if you had a third, like let's say you changed your Teflon line between the inline filter holder and the back of your instruments, there's room for 3 different multiple diameters. And again, this is our new calculation. So where can you find all this information? You can find it QA Handbook 2, or you can find it on ARB's QA webpage. You can be able to get this form. What happens when you don't meet the 20 seconds? A corrective action notification. I think we talked about that yesterday quite a bit. And we can have the station operator take action. Many times the station operator, if you're close, they're able to make the adjustments while we're there, and we can take it again. It's one of the most important things at a monitoring station. The hardest part is determining the inner diameter sizes and the lengths of your stuff. Maintain the residence time below 20 seconds. Questions?
Hi. Is there any way we could get a section on that spreadsheet for entering volume directly rather than the dimensions? Because we measured our manifold just by filling it with water and taking the volume directly that way.
You know, I don't think we've developed. Does anybody else develop a spreadsheet that does that for volume? Bay Area has? Okay, yeah. I have heard of that method of doing calculations.
I mean, we've got our own spreadsheet, so we can. I was wondering how much you guys preferred us use your spreadsheet. because we can document it directly our way as well.
Okay. As long as you come out with your seconds and we can verify it mathematically, it'll be good.
Is there any consideration for through the probe calibrations, the time of the ozone calibration, for instance, of the going up to the up to the inlet and then back down? Do people calculate that in their residence time for calibration, for instance?
You know, that's a good question. I don't know if people do. You'd have to ask the calibrators. Do we have any calibrators in here? If they've ever decided to make that determination, I guess Mike will answer. You got to put you on the spot.
Are you talking about when we do the audit or when the station techs themselves? Well, I don't believe residence time is a factor when you're doing your calibrations themselves. I believe residence time is more of to represent if there's any type of reactivity in your probe line. So that's why they want to keep it below 20 seconds. And I'm not sure. I'm going to have to check on that one and get back to you in terms of calibration procedures. I don't know. Kate, do you have anything on that?
I think it's taking it into account because you're shooting your known quantity, and that the difference between that and what you measure on your instrument that you're calibrating is taking any line loss into account, and that's why it's a good idea to calibrate that way because it accounts for that.
And there's some districts that have these very large probe inlets made out of glass. San Diego's one of them. Those are very difficult for us to measure. So if people have already done the calculations, it really helps us when we get out there to just double check their calculations.
One other question on the requirements for frequency of measuring residence time. Is it annually? You have to do it once a year minimum. Is that correct?
Minimum of a year, and then anytime there's an instrument change, you should recalculate residence time. How often do you guys changing out your probe lines? Do you guys have any once a year? Yeah, most people are doing them once a year. If you're in an area where there's a lot of wildfires, I would suggest that you change them after wildfire season because you're having a lot of particulate inside your probe, which could react with your ozone. That's it? Okay. I guess lunch, huh?